Continuing our MySwing 6 video series, here we're looking at our fifth feature, the Kinematic Sequence. The first features dealt only with the avatar and the settings. The last two features will dive a little bit deeper into the graphs. As you can see, I've got the same player that we looked at in the lead arm adduction video. We've got a 24-year-old former college player, decent club head speed, pretty athletic, tall young man. We'll open up the graphs, and our first graph we'll look at, or we can see, is the kinematic sequence. What is the kinematic sequence? The kinematic sequence measures rotational velocity of the pelvis, the lead arm, the rib cage, and the club. It's basically measuring the transfer of energy from the ground up. Your sequence. We can expand the graph a little bit. We'll go ahead and look at it in full screen. A few things to notice. This scrolling bar is actually the position of the avatar. The first red line will mark the top of the backswing. The second red line will mark impact. Any line that moves below this zero line means that there's movement away from the target. Any line above the zero line is movement toward the target. The x-axis is measuring time. The y-axis is measuring degrees per second. Again, this is rotational velocity. And we're looking at the pelvis is red, rib cage green, lead arm blue, and the club. This will just be a real quick overview. First thing we want to look at is, when does this player transition? And how do we define transition? Transition for each segment, so transition for the pelvis is going to be different than the rib cage and so on. And what I mean by transition is change of direction. When does this player start to rotate his pelvis toward the target? And it happens about right there. The proper transition sequence is pelvis, rib cage, lead arm, and club. We want the pelvis to change direction before the rib cage. We want the rib cage to change direction before the lead arm, and then the club to change direction last. If this was backwards, if the club changed direction first, you're going to have a typical over-the-top slicer that doesn't have any power. As we continue on, we'll see where the rib cage starts to transition, so somewhere right around in here. And then the lead arm is going to change directions right before the club does, which is just before the top of the backswing, and then obviously the club's changing directions at the top of the backswing. We'll go ahead and make the graph full screen. This phase is the downswing phase. So again, red line's top of backswing. The first red line's top of backswing. The second red line is impact. After transition, the next thing that's important is the peak velocity, or the peak speed of each segment. What we would prefer to see is the pelvis reach peak speed before the rib cage to reach peak speed before the lead arm, and then obviously the club to reach peak speed right at or just before impact. As you can see with this player, his peak pelvis speed is a little bit late. If we could get his pelvis speed to peak somewhere right around in here, then the sequence would be in pretty good shape. If you see a player that their red, green, and blue lines all match, this term is known as riding. And if you see big gaps in each of the curves, so you see a pretty big gap in the red and the green, you see a pretty big gap in the red and the green here, this is considered stretching. The more the stretch, the more possibility for speed. What we normally see is with riders, we see a lot of riding on little pitch shots and control shots. Last thing you want to check is when and where the players are decelling. So when is this line starting to go down? When is the rib cage line starting to go down? There's a common misconception amongst golf instructors that there's no deceleration of the pivot or the pelvis in the golf swing. Imagine trying to throw a rock as far as you can without your shoulder ever slowing down. So if you're going to throw a rock as far as you can, your right shoulder will always start, but then it's going to slow down. And it slows down because your elbow starts to speed up, and then your elbow slows down because your hand starts to speed up. if the pelvis never slows down, you're never allowing the rib cage to speed up, or better yet, the rib cage is never speeding up fast enough. So this deceleration has to happen, has to occur, one, to help transfer of energy, but two, to decrease the risk of injury and to help stabilize everything else. So again, looking at the kinematic sequence, we looked at the transition phase, we looked at peak speed, when and where it was happening, and then we covered the deceleration phase.